Hello, hi everyone. So today we will be solving one another interesting problem number 347, top k frequent elements. So the problem says given an integer array nums and an integer array k, return the k most frequent elements. You must return the answer in any order. Okay, so the input look like nums is equals to 111, 22, 33, and k is equals to 2. So the most frequent elements that we can have, so if I make a initial dictionary out of this, so we'll have something like this. One has come 3 times, 2 has come 2 times, and 3 has come 1 time. So the most frequent elements are 1 and 2. So we'll return something 1 and 2, because so what we can do is we can create one dictionary which will create by traversing the nums list, and then we can sort that dictionary in descending order to get the element in the sorted list, and then based on the frequency we can pick up the elements and store it in an array of answer which will return. Okay, so here is how we can do it. So the very first thing we need one, will convert the whole nums into a dictionary, and then we'll need to sort this on the basis of on the items of the dictionary. So and we'll use one lambda function to do the sorting based on the frequencies. So we'll be sorting the dictionary based on frequency, and we want the elements in reverse order, so we'll do reverse is equals to 2. So we can see how our elements look. So let's run it. Oh, sorry, key is lambda. Right, and now command R, key is equals to my bad, lambda x1. Okay, so we have the list as tuples with key as the element and their count as the second element in the tuple. Okay, so now what we can return is, we want to just return the top elements from this list. So we'll return I for, or you can say for key, comma frequency in list. Okay, for key comma frequency in list, yes. So from here we want to return, and let's run our code and see how does it perform. Okay, so we have 1, 2 and 3. Okay, we want to go up to k elements. So okay, let's run our code and let's submit our code and see how it's much faster. Okay, it is faster than the too many people, but here in the problem it says that the time complexity must be better than the n log n, and here our time complexity is essentially O of n log n, and it is why it is n log n, because we are doing So we are converting in one pass, we are creating the dictionary by converting it into by converting the array into dictionary. So that is one pass O of n, and then we are doing the sorting over here, so which makes our algorithm to go till n the number of elements of the dictionary, and it is making us to do the time complexity to be n log n, right? So now the thing is, can we do better than this? And the answer is yes, we can do better than this. We can use heap to our help. So what we can do is we can create one heap, and so first we'll create one dictionary, simple, the way we created before. And after that, what we can do is we'll store uh, the elements by pushing the elements from the dictionary into a priority queue or heap, uh, into a maximum heap based on the frequency. So what we'll do is we'll put it in like this. So we'll do -1, -2, and -3. So this would be our priority queue. This would be our maximum heap which we will be putting, and now from this we will be picking out the elements. From this max heap we'll pick out the element and store it into our one answer array that we just want the maximum elements from this. So the maximum element corresponding to 3 would be 1, and for 2 would be 2. So that's how we can do it using the max heap. So here is how we can write the code. So we'll use the counter to convert our whole or nums array into a dictionary, and then we'll use one maximum heap, and to invoke the heap module in the Python, we can directly use the heap module from Python library. So from heap queue import everything, and what we need is for the number and their frequency from in thought items. We want to push the number and its frequency into our heap that we just declared. So you can see how our heap looks. So it will look like this. C dot items. Okay. Heap push. Okay, so this is our frequency, and that is the element that we are looking for. And now we'll append now we want these element from the max heap list that we have created to return as the answer. So for that we'll go in the, because we only want to go up till the number of elements that we want to capture, which are basically k. So we'll go up to k, and after that we'll just put it into our answer. So we'll have an answer array, one answer list, and we want the number from the after popping from the max heap that we have created and append it into the answer that we just created. So answer dot num, and at the end we just want to return this answer, and let's see how does it perform. Okay, let's run our example test cases. Okay, good, and let's submit our code. Okay, it's running good, it's fast, and the time complexity for this problem is O of the number of, so creating the initially for creating the dictionary would be O of n, and then for traversing the number of elements in the dictionary item, so that would be the number of elements in the dictionary. So let's say the number of elements in dictionary are m, and after that we are traversing it up till k. So the number of elements, so the time complexity for this traversal is O of k, so ultimately which becomes O of n, because since here n is greater than m and which is also greater than k. So yeah, that's our time complexity for this problem, which is definitely better than what we are supposed to return. And the space complexity is O of O of m, because m is the size of dictionary which we are using once, and then after that we are returning O of k up till k, so which makes the space complexity of O of m, since m is greater than k. So to do a dry run for the problem, so what we have done is actually we have done something like this. So for the very first time when we have the element, we convert it into a dictionary with the frequencies, that how many times that number has appeared. So 1 has appeared 3 times, 2 has appeared 2 times, and 3 has appeared 1 time. And after that we have created one max heap based on the frequency. So what are this are turned basically into -3 is the frequency for 1, and then for 2, and then for 1 the frequency was -1. And now we have the elements stored in the form of, in the maximum heap we have the elements stored based on their frequencies, and from this maximum frequencies we want to pull out just these elements which has the maximum frequencies, and we want to run that up till the k number of elements, k number of times that we have been provided. So we have run the next loop until k to capture these uh, items, so in the answer that we just created. So yeah, that's how you solve this problem. Thank you.